Hello and welcome back. This is another 8th grade math video, and in this video we're going to be focusing on how to do multiplication with numbers that are written in scientific notation. Okay, here is our first example. We're going to take the scientific notation of 2 times 10 to the second power and then multiply that by 3 times 10 to the fourth power. So real quick, I want to talk about a concept involving parentheses. Now, you may have seen this before and you may not have, but when we have two numbers or expressions in parentheses where there is nothing in between those parentheses, that means to multiply. So essentially what this is telling us to do is to multiply 2 times 10 to the second times 3 times 10 to the fourth. So we're actually going to rewrite this because it'll make more sense on what we need to do. We're going to rewrite this as 2 times 10 to the second times 3 times 10 to the fourth. So as you know in math, when you multiply or you're only multiplying or adding, it doesn't matter what order you do it in. So that means we can just go ahead and multiply this straight across. We don't even have to worry about the parentheses or any kind of order that it would need to go in. So what we're going to do is we're going to multiply like terms. So we're going to start here with the 2 and the 3. 2 times 3 would be 6. So I'm going to go ahead and write that here as 6. Then I'm going to cross those off. Now I'm going to multiply the powers of 10 as if they were their own like terms. So I'm going to come over here and I'm going to multiply 10 to the second times 10 to the fourth. So if you've seen some of my previous videos on multiplying with exponents, you know that as long as the base is the same, you're going to keep that base when you multiply, and you're just going to add the exponential numbers together. So 2 plus 4. Well, 2 plus 4 is 6. So this is going to become, as our answer, 6 times 10 to the 6th. The last thing we need to check before we submit this as our final answer is just that it is written in scientific notation, because sometimes, as you'll see, when we multiply it, it comes out a little bit of scientific notation we need to adjust. But in this case, it is still written in scientific notation because there is only one whole number in front of the multiplication sign. All right, so then this is our final answer, 6 times 10 to the 6th power. Okay, here's our next one. We're going to take 6 times 5 times 10 to the fourth power. So again, with the parentheses, that just means to multiply. So essentially, this is a multiplication expression that can be written as 6 times 5 times 10 to the fourth. So we're really just multiplying all these like terms together. So the like terms I see are the 6 and the 5, because both of those are whole numbers. They don't have an exponent. So 6 times 5 is 30. Then I can cross those off just so I know I'm done with them. Now there is no other exponent or power of 10 for me to multiply 10 to the fourth by, so I'm going to just bring it down, 10 to the fourth. So this is the answer that we get, 30 times 10 to the fourth. However, that is not written in perfect scientific notation because it's got 2 digits of whole numbers. For scientific notation, we need only 1 digit of a whole number. So I'm going to rewrite this answer that I've gotten so far into standard form, so then I can rewrite it back into scientific notation. So I've done a previous video on how to convert between the two. So if you'd like to check that out, that would be great. So 30 means I'm going to write 30, and then I'm going to add 4 zeros. 1, 2, 3, 4. Okay, so 30 times 10 to the fourth is essentially 300,000. But I want to rewrite it into scientific notation, which means that the decimal, while it's sitting here, needs to be sitting right here so that I only have one whole number spot. So in order to get it from there to there, I need to move it 1, 2, 3, 4, 5 times. So that means it's going to be 3 times 10 to the 5th power. So that is the same amount, but now it is written in scientific notation. So final answer is 3 times 10 to the 5th power. Okay, here is my next one. We're going to multiply 3 times 2 times 10 to the 0 power. So let me go ahead and rewrite that multiplication expression. That is 3 times 2 times 10 to the 0 power. Okay, so 3 times 2 is 6. So I'm going to start with that, times. And then there's nothing else for me to, or no other power of 10 for me to multiply that with. So that's just going to be 10 to the 0 power. So if you've seen some of my previous videos about exponents, you know that any base to the 0 power is the same as 1. So I'm going to replace this with 1. So essentially, our answer is going to be 6 times 1, which is 6. So that is our final answer. There is no power of 10 anymore. So the final answer here would be 6. Okay, here's our next example. We're going to multiply 5 times 10 to the 9th times 4 times 10 to the 1st. So again, I'm going to rewrite this as a multiplication expression. I'm going to rewrite it as 5 times 10 to the 9th times 4 times 10 to the 1st. Okay, now I'm going to go ahead and multiply like terms. So I see a 5 and a 4 here that I can multiply. Well, 5 times 4 is 20. So I'm going to go ahead and write 20 right here and cross this off. Now I can multiply the like terms of the powers of 10. So 10 to the 9th times 10 to the 1st means I'm keeping 10 as the base, but then I'm adding 9 plus 1, which is 10. So this is my first answer. It's 20 times 10 to the 10th. But the problem here is that this is not written in scientific notation. So I need to convert it to proper scientific notation by first converting it to standard form and then converting it back to scientific notation. So to convert it to standard form, I'm going to rewrite 20, and then I'm going to add 10 zeros to that. Yes, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo, that's a lot of zeros. That is a big number. Okay, so now what I'm going to do is I am going to first pick a color that's going to stand out a little bit. There we go. I'm going to add a decimal to the end of that answer. Now I need that decimal for proper scientific notation to end up right here because I can only have one number or one digit in the whole number spot. So that means it's going to be 2 times 10 to the something. That little exponential number is how many times I have to move the decimal to get it to the right spot. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the 11th power. So our final answer to this is 2 times 10 to the 11th power. Okay, here's our next example and our last one for today's video. We're going to multiply 4 times 10 to the 1st times 5 times 10 to the 4th. Okay, so we're going to rewrite this as 4 times 10 to the 1st times 5 times 10 to the 4th. So I rewrote that as a multiplication expression, and now I'm going to multiply like terms. So I'm going to multiply the 4 and the 5 together, which gives me 20, and cross those off. Then I'm going to multiply the powers of 10 together. So that's going to be times 10. But when you're adding two exponents that have the same base, you keep that base of 10, but you're going to add the exponential number. So you're going to add 1 plus 4, which is 5. Okay, so this is the first answer I got. Now I need to check and see if it is in proper scientific notation. It is not, because there is more than one digit in a whole number spot here, and I can only have one digit as a whole number in scientific notation. So I'm going to rewrite this back into standard form and then convert it back to scientific notation. So I'm going to start by writing 20, and then this tells me how many zeros I'm going to add. 1, 2, 3, 4, 5. Then I'm going to place a decimal at the end of that. And I need to move that decimal so that I only have one digit in a whole number spot, which means I need to move it so it's right there. So this is going to be 2 times 10. And then the number of places I need to move the decimal to get it to the right spot tells me what the exponential number will be. So let's see, this is 1, 2, 3, 4, 5, 6. 6 spaces. So the final answer here is going to be 2 times 10 to the 6th power. All right, you guys, thank you so much for joining me today. I hope to see you in another video soon.